And that does seem to help in a lot of the cases. All right, I've turned off location services. Go ahead and try joining now. Successful? Anyone need another second to join? A couple more seconds. Does it show that you're in the class?
Yeah, it shows I'm in the class, but it's not saying that it's going to this session.
No, it's because you've already joined. Probably, is my guess. All right, we in? Okay. We have 43 people who have clicked in a response here. Why don't you go ahead and, since we just saw some people just arriving, make sure everyone's gotten a chance to try working through this problem. I want you to show your work. And we're going to be utilizing the packet from last class today, so if you don't have that out, go ahead and get that out. Say again? iClicker website? iClicker Reef, I think, or should be able to get to it from just Google iClicker Reef.
It doesn't. It's a multiplication. So if you're adding 125
Cool. Did anyone forget to bring their packet back? Need that? Oh, no, we're good. Keep your hands raised. Emily will hand those out. That's kind of not very useful for the people raising their hands, sorry. All right, keep your hand raised if you need the packet as Emily walks around. That's the separate raising the hand.
Oh, the packet we already were given?
The packet you're already given, if you forgot to bring yours, then Emily has a couple extras. I think I only have like 5 or 10 extras, so I think she might almost be out. But there's one or two more. Keep your hands raised if you need that. Can I have a volunteer for what the setup would look like, describing that?
This one?
This problem that's up on the screen. We're going to try to get as many voices as we can today, so I'm going to try to limit everyone to one response. So pick your responses. Yeah, Caitlin. Yeah, how to set it up.
First, well, at least how I did it, we'll do 25 kilograms equals 25 kilograms over 1, and then you'll multiply that by 2.205 over 1 kilogram, and then you'll cancel out the kilogram.
Okay. We're on the right track, but I think that this first part over here might not be a necessary step because we're basically saying that's our starting quantity. So I'm going to go ahead and erase that because then we have kilograms in multiple places, right? So if we erase that first part, then what you're saying is that we now have converted from kilograms to something else. But what did we convert to here? But not in the way that you described it. Maybe I didn't write down everything that you had on your paper. I just wrote down what you described. So what am I missing here? Pardon?
Put the units up there next.
We're missing the pound, sorry.
Great. And you might have had this on your paper, so I'm not judging what you had down. But it's the most important part of the conversion, right, is that our conversion factor is it allows us to go from the unit of kilograms to the unit of pounds. And so if we don't have both of those units in the conversion factor, then that's a big red flag. So as we go forward in the semester, I know we're doing very simple things in class. We're going to ramp it up pretty quickly, and we're going to be doing a lot of really complicated conversions through the entire semester. This is a skill set that's going to serve you very well. So always include your initial units. If it only has units on the top, unlike the milligrams per kilogram example in your homework, then just put it over 1. If it was milligrams per kilogram, then you would do, I don't know, maybe it was whatever that is. Then our initial value, do I put that over 1 if that's what we're starting with? No, because that has units on the top and the bottom. So that's where the 1 doesn't come in. But I want you to differentiate this kind of a problem with the 1 versus the kind of problem that already has units on the bottom. So if we do that calculation, then I have a couple different answers here. What answer would be correct? Why? Why is it not 55.125, or why wouldn't we include more significant figures there?
There's only 2 significant figures and the smallest 1.
So that is the appropriate number of significant figures. And the reason why is if we go back and we look, we have 2 significant figures for the starting value. And that conversion factor, 2.20, and it depends on what we had. I think it was 4 or 5 actually, or something like that, right? That should not limit our answer. Why? Why should that conversion factor not limit our answers significant figures? This is one of the most frustrating parts for students learning about significant figures.
What's the question?
So when do you limit an answer sig figs based on a conversion factor, when do you not?
When you multiply
Can I go look up a more accurate version of that conversion factor from pounds to kilograms? There's like some number that has maybe 30 significant figures that they measured it so precisely that we're not going to say that we're going to limit our answer by 2.20 pounds per 1 kilogram, because we can go look up an even more accurate version of that, and in fact we should look up the most accurate version when we're using it. What that means is that this is not going to limit our significant figures. The term that's used for that is that it's a precise number, or it's not an exact number, but it's something that if there's more precision available somewhere that you can look it up, you're not going to put in the entire number that you can look up somewhere else. So you have a shortened version of it, but then that doesn't influence your significant digits. However, this object, we put it on a scale and we said, how much does this weigh? Did we say it weighs 25.0 pounds, or kilograms? 25.00? So that means that that's not a very accurate scale. So that's probably the kind of scale, it's probably even worse than the scale you have at home to weigh yourself, right? My scale at home at least tells me point something, it gives me the tenths place. So this isn't even that accurate. So if I were to give this answer with 3 significant figures, 1 past the decimal, I'd be making up significance that's not there. We'll spend a lot of time on this semester, but we want to kind of keep that in mind as we go. If you are not 100% confident in the homework and the pre-class quizzes and the post-class quizzes that we're doing, there are a lot of free resources here on campus. I don't know that everyone is aware of all of them. Is Math Assistance Center something that you're aware of or heard about? There are emails that go out about it, but the 4th floor of ETAS, the building just next door, you go up to the 4th floor and it's like one of the major things. It is staffed for like 70 or 80 hours a week with tutors for free, paid for by the university with your tuition dollars. Take advantage of it. It is there to help you. And especially in the beginning of the semester, where we're just doing mathematical operations, and that's the main focus, those people are just as capable as any of the chemists for helping you. So if unit conversions is something you're not quite sure about, if there's a specific problem, go there for half an hour before your homework's due. On a Sunday, I think they're open, what are the hours? Sorry, they're open Monday through Saturday. 9 to 7, Monday through Thursday, Friday 9 to 2, Saturday 10 to 2. Not open Sundays. They do online tutoring as well. You can put in a request. So a lot of hours throughout the week. Definitely a decent option. Chemistry tutoring office, if you want to see the hours for that, that's if you go to our Blackboard homepage. There's a link, or I think maybe just an image of the tutoring hours. And that's on the 4th floor, right above where you have lab. So just take the elevator up to the fourth floor in the science lab building just next door, walk out around the corner, and it's there. And that's chemistry graduate students or chemistry majors, so people that are very useful. And then my office hours that we talked about last week, I'm also available by appointment. If you feel like you're getting lost, don't go too far with that feeling. Come see me, that's what I'm here for. My job is to help you succeed. Any questions on the resources that you all have? Has anyone formed study groups yet? Too early for that? Okay. We got a couple. As we go through these group activities, talk to the people around you. Try to figure out, do you have overlapping schedules? Can you stay after class or come before or come on a weekend or whatever it is? Find the time that works. Studying and doing the homework, sitting next to someone is a fantastic way to get over those little barriers. You might just be misreading something or just get stuck on something. And instead of waiting for an email from me, study with someone else. So much more efficient. Should you also do that for the post-quiz? No. Post-quiz you need to do on your own. That is the one part of this class as of right now, and exams that you should do. But based on the plagiarism test, does that mean that you can turn in identical material? Like literally picture perfect? We worked on it together. It's the same piece of paper. We're just going to hand it in, right? So if I do require anything to be turned in, you need to make sure that I know you worked with someone else, that's fine, but that your work is your own work. I don't want to see anyone turning in the same piece of paper if it's an individual assignment. We'll spend a bit more time on that as we have assignments that are due like that, but that has happened before where students say, oh, well, we worked on it together, so we just, basically photocopied it. That's not cool. Okay?
Our exams are going to be here, like on paper, right now.
Correct. Your exams will be in class. And going back to Eleanor, you had two questions.
Oh, yes. It was just about, what sort of material do we need to absorb from these chapters? Because when I was reading chapter 1, there was so much in it that we in no way covered. Like, I forgot what it's called. The heat and the gravity, whatever. Oh, yeah, specific heat, specific gravity formulas. Like, what do we need? Like, how are we supposed to know what we need to take our time with? I know, obviously, we're doing what we're doing, but I didn't know, since you said this was an interactive class, if, like, some of this stuff we just won't talk about in class, but we still need to know it. If we don't have it on the test, we're going to fail.
So this was a question, I got something similar in an email or Blackboard post as well, and I wanted to address it with the entire class. I will direct you to what I think is the most important things for you to be able to do in this class. That means that the assignments I give you, the in-class material, the labs, and the homework, that is what I will assess you on. There is other material in that book that you may find very interesting or you might find very applicable to your job or your future job, and that is fantastic to see it as a resource to use. You paid for it, make sure to get good use of that. But I will not assess you on a topic that we do not spend any time on in class. The beauty of this class is that there is no standardized test at the end, so I do not have to give you a test on everything in the chapters. I think that allows me some freedom to pick what I think is going to benefit this class the most, and I can focus on those concepts and those topics, and that means that you don't have to go out on your own and learn everything else.
Okay, thank you.
I have a quick question. You said you kind of oversee lab as well. Well, I had lab last Wednesday before this class, and I was just lost more after lab than I was starting. I don't know if that was just a first day thing or if it was just...
So maybe that's a conversation that we have offline, because I want to hear about it, but I don't know that that's something I need to address with the entire class. Labs should be a mechanism to support some of the things that we're learning in class, but some of the things you may learn there first, and it may be kind of fuzzy. You might come to class, and then we might build off of that. Depends on the week. The last comment was, someone asked me, do I curve exams? The answer is no. I set my assessments as to what I expect my students to be able to do. If everyone is able to achieve that, then everyone gets 100%. Curving means that the average is 70%. I do not believe in curving exams. If I'm giving an assessment where the average is 40%, it means that my expectations are really off, or my teaching is really off, or everyone in the class doesn't get it, which is not possible. So my assessments will align with what I expect, and That should be very clear from what you see us do in class. And so there will be no curving. The grade you get will be the grade you earn on those assessments. I think that's all the logistics. Well, one other piece of logistics. Have you all spent a lot of time on Blackboard? Yeah. In our Blackboard? A lot of students are going and getting stuff done, but some are still not connecting things, and so I just wanted to point them out. If you go in our Blackboard course shell, and you go under the Mastering Homework, this is where I thought most of you are probably going anyway or know how to go. There's a few things I need you to do. If you have not already, click on this iClicker Sync button. It'll ask you to log into your iClicker account, and that's it, done. You don't have to do it right now, but please do that because that means that your grade will then be able to come from iClicker into Blackboard. If it doesn't, then I can't get your grade in Blackboard, and I don't have a manual way to do that. There's a syllabus quiz because we didn't spend the first day on the syllabus, so that should not take you very long. If you go through it the first time and you get things wrong, it'll show you the right answers. But just pull up the syllabus, do Control F to look through it to find where the answers are. Should be pretty straightforward. Plagiarism certificate test. Make sure you have this uploaded. There's an assignment in Blackboard where you can upload an image. Yes?
For whatever reason, I can't actually access the plagiarism certificate site at all. Like, I can't.
So copy the URL and put it in another browser.
Yeah, I've done all that. I've tried that.
Let's catch up after class.
Okay.
Okay, unless that's a common problem across class.
I just uploaded it last night, and it
Okay.
uploaded all crazy. It didn't look anything like that.
Okay, I'll look on my back end. If you're concerned about what it looks like on my end, feel free to send me an email and say I'm worried about what it looks like when I uploaded that document. The last logistic thing for today, do you remember the first day of class? I know there's a lot going on. I showed you data of effectiveness of different teaching approaches. I collect data on my own classes as well because I want to know if what I'm doing is effective. Part of that is built into the survey that's here. Some of this is about attitudes of science. What are your beliefs about your role in science, about other people's role in science? And then there's some questions about concepts in chemistry, so technical questions. This will count as a pre-class quiz. So if you complete it, it's 100%. It adds on to that, and it pads your pre-class quizzes. Please don't just click randomly through it. Just read the questions. It shouldn't take more than 10 or 15 minutes at the most. But this is something that I use to determine whether I'm effective in my teaching or whether I need to make changes and adjustments.
That's the survey assignment?
Yep, that's the survey assignment right here. And you don't need to do anything aside from click on it. It'll ask for your email. You put in your email. I don't look at your specific responses, but I do something similar at the end of the semester, and I use the email to match and to see where I had an impact and if there are changes over the course of the semester. Okay, so please just make sure that when you go in there, you put your email. There's nothing to upload. Just finish the survey, hit submit.
My grades in the national. Is that normal?
Let's look at that after class.
Okay.
I'm not sure. All right, any questions on the survey? All right. So by the end of class today, I want to work on the same things we were working on last class, but going a bit deeper. I want you to be able to identify and apply conversion factors. And we're going to start converting between SI units. Does anyone know what SI stands for? International Standard, of course. It's not IS. Literally, it's International Standard. I don't know why they have it as SI instead of IS. So we're going to be using a lot of those conversion factors, and we're going to think about where they come from and how useless some units are. And then we're going to continue this kind of verbalization of units. So we're going to have a speed round. All right? Do not use your digital devices to answer these questions. Ready? You can answer on that, but don't look up the answer. You know what I'm saying? Don't look up the answer, but you're going to click in your responses. I'm giving you 15 seconds per question. Okay, ready? Ready? You can use a calculator, sure. As long as you're not looking up the answers or using it to answer your question. And go.
Oh, wait.
25 responses. We're at 15. I'm going to give 5 more seconds. Submit a response. If you don't know, then just guess. Closing out. And closing. 12, 36, 32. Could we figure this out? How can we figure this out? All right, so what's our starting quantity?
1 yard is equal to 3 feet. And then 1 foot is equal to 12 inches.
Okay, we could do this, right?
Yeah, it would take longer than 15 seconds to set that up.
It's pretty easy, pretty straightforward, right? Fantastic units, like everything makes total sense. All right, let's do the next one. All right, in 10 seconds. All right, we're going to 20, just because I only 20 responses. Come on, submit a response. And closing out.
Oh, is that like a pint of ale?
15, 12, 85, 16. Come on, isn't this, I mean, this is the measurement system of the U.S. Don't we all know exactly how many teaspoons or tablespoons there are? Pint is a form of measurement. It's formal, it's 16 fluid ounces. And a tablespoon is half an ounce, it turns out. Okay, let's do another one. How many centimeters are there in a meter? Couple more seconds. Closing out. Okay, 62% of the class got that right. There are exactly 100 centimeters in a meter. All right. How many grams are there in a kilogram? We're getting into some pseudo nursing units.
Well, it does matter, but you just have to be able to convert it to ounces.
Closing out.
If a pint is 16 ounces, it's like the liquid equivalent of a pound being 16 ounces. Not 16 ounces.
All right, we have 62% of the class that seems to be a little bit comfortable with the metric system. From those last two questions, 61, 62%, all right? So, it is 1,000 grams are in a kilogram. And how do we know that?
It says kilo.
Kilo means 1,000. 1 times 10 to the third. So it's basically 1,000 grams. And if you look at the worksheet for today, if you flip it over the backside, there's a whole set of metric conversion factors on there. Yeah, Lena? The single sheet of paper that was handed out today. If you did not grab them, they are in the back. Every day when you walk in, there will be some sort of paper on the back. If there is not, it is one of the only days of the semester that there's not.
We got here before you did, so we didn't think we did the paper.
It does look like it's more so the people that arrived before I did. No judgment. Judgment's on me, if anything. I should have let you know earlier on.
Okay, I'm having a slow moment.
I was like, back in the sheet, I was like, I don't see anything.
Isn't it 1 gram per 1,000 kilograms?
1 kilogram per 1,000 grams. Yep. And this is incredibly easy to do. So it's really easy to mix it up and flip it around. And so we're going to make sure that when we convert between any sort of units, we're always going to write it out in unit conversion form so we can see exactly what that relationship is. So Lena, you had a question. You remember it?
Yes. Will we have this on the test?
No, you will not
Okay.
have access to a table. There are very few things in this class that I think that you should memorize. And ideally you don't memorize this, you learn how to use it. But there's a few that I'm going to highlight that you should really focus on. And those are actually highlighted with a little bit lighter color. You can see the name on the far left.
So we don't need femto.
It's interesting, but no. When someone says nano, you should, know that it's something very small.
Yeah.
And 10 to the negative 12th, I think, is that what it is?
Negative 9.
Damn!
You're thinking
I'm glad we're not recording this.
pico is the negative 12.
Alright. So, let's back it up for a minute. We compared and contrasted two different sets of units. The top two are standard units or imperial units. What do those have in common with each other? What do inches have in common with yards? What's that? Okay, so they're a measurement of length. What about those conversion factors? Sam? Okay, so there's some sort of standard that's set somewhere. That's about it. What about our metric units or our SI units? What do they have in common? All powers of 10. So if you look at two different units, you're going to see that whether this is a 100-fold difference between meters and centimeters, 1,000 with kilogram and gram, you're always going to have a base unit of 10. Which would you rather try to memorize or utilize on a regular basis? So talk to your neighbor and see if you can remember what this imperial system of temperature, at least, is based off of. See if your neighbor knows, or see if you know.
I remember reading that, but I see it, but I can't regurgitate it.
So I just gave some random values up here that might be interesting or useful. Does anyone have an idea they want to share?
Yes.
No. All right, JP, what are you thinking? Where do these come from? Okay, don't offend people. Let's not do that. Any ideas?
About what?
Where do these come from? Where does the scale come from? Why do we have the scale of Fahrenheit? Sam?
Isn't it the freezing point of alcohol?
Close. Close. What would the freezing point of some weird solution be?
0 Fahrenheit?
So there's this number of a scale that'd be really nice to say, what's 0 to 100? This guy, Lord Fahrenheit, said, well, we're going to base a scale off of 0 and 100. Makes sense, right? 0 degrees Fahrenheit is the freezing point of saturated salt water.
Nice.
Okay, useful. And what was 100 degrees?
Boiling point of saturated.
Take a guess, he was wrong.
Oh,
Oh, he thought that was a boiling point.
body temp.
Body temp's 100. That makes sense. So our whole Fahrenheit scale is based off of freezing point of salt water and body temp, but he was wrong because he wasn't accurate at the time. Okay? The one, I will say that not living here, but if you live anywhere that has snow, this number is actually a little bit useful because you know that when it's getting close to 0 degrees Fahrenheit, even the salted roads are going to freeze. That's about as far as I'd go as far as the usefulness of Fahrenheit. What about the metric system? Same measurements, but now we're looking at a different temperature scale. Chris?
Off of water, right?
Based off of water. Freezing point of water at 4 degrees Celsius. Sorry, that's another thing. I'll get back to that. Makes no sense at all. Freezing point of water is 0 degrees Celsius with nothing dissolved in it at all. And then the temperature at which water boils at atmospheric pressure, which is sea level, is 100 degrees Celsius. Body temp happens to be 37 degrees Celsius. It's not a reference point because humans are complex organisms, and who's to say that that won't change over time? Which one of these would you rather use?
Fahrenheit, just because we're used to it.
You're used to it. But what I'm asking you as scientists is to start getting used to this scale. And it doesn't stop there. So this scale continues. What else is, well, let's go there. So Kelvin is a different scale as well, right? So there's a whole bunch of physicists and chemists who looked at this and said, okay, well, at 0 degrees Celsius, stuff is still moving. Gases still exist. So they said, let's cool those gases down and see how cold we can get them before they completely stop moving. And what they found with a lot of gases was that they cooled them down, cooled them down, cooled them down, and they all turned to liquid before they got to no motion at all. But what they figured out is there's this theoretical temperature at which there is zero energy, that there is no movement of any particles. And so they said, well, at that point, we're going to call that absolute zero. That's the coldest anything could possibly get in the entire universe, and we haven't proven it otherwise since. And so we're going to call that temperature. So it's absolute zero, and it's 273 degrees below freezing Celsius.
In the book it says 273.15.
True. If we use sig figs, we should. 0.15. So that is the coldest the universe can get, is keep going, boiling water, body temp, freezing water, all the way down 273.15 degrees further. And so then they said, well, let's make that the actual scale of temperature. So let's say that our zero, Lord Kelvin, was a physicist, and he said, I'm going to call this zero. This is my zero. But he's going to use the same steps. So 1 degree change in Celsius is still 1 degree change in Kelvin. It's just Lord Kelvin's scale. And this is Celsius' scale. Okay? So these two are really an identical scale. It's just we're saying that instead of the zero being freezing point of water, let's make it about the universe instead of about water. Any questions on that? So if I say that let's warm the room up by 3 degrees Celsius, how many degrees Kelvin are we raising the temperature by? 3 degrees. Same exact thing, right? The steps are the exact same size. All right, so this is the actual SI unit is Kelvin. Sometimes we use Celsius interchangeably, but that's kind of what we center around. But then what about all the other measurements? What about length? What about mass? Would you believe me if I said those are all based off of water too? I'm trying to remember if I have a visual for it in the next slide. So if we had a little cube, I'm not very good at drawing, but I'm going to try. If we had a little cube, and it was, we're going to say that this measurement, we're going to call it a gram, however much it weighs. It's a cube of water. And 1 gram of water is 1 centimeter by 1 centimeter by 1 centimeter cubed. And that's a measurement in metric system. So this is length and mass. What are we going to call the volume of that one? In nursing language, what is the most common form of, think about it, it's 1 centimeter by 1 centimeter. A centimeter is about this big. It's about 1/3 of an inch-ish. How much volume is that in nursing speak? Not in nursing speak. It's a cubic centimeter.
Oh, is that where that comes from?
And we also call that 1 milliliter. So all these things are based around water. That's the metric system. It makes so much more sense than the standard or imperial system. But yet, we're America. America. I grew up with European parents, so to me this is just complete gibberish, this whole Fahrenheit, inches, pounds. Yes. Even the British that invented the imperial system don't use it. They use kilometers per hour, they use length in meters, sometimes they do weight in pounds, but for the most part they even gave it up. We're just stubborn. So I'm trying to bring home the point. The main point is that the metric system is all based off of water, and it's all based off of powers of 10. So a big challenge can be trying to remember what the prefixes mean and how to utilize them. This is literally a photo out of your book, So this is also on the printout that you have in front of you. It's on the back side at the bottom. The ones that are the most important are highlighted in blue, these little bit lighter colors on your page. And so if we're saying we have a standard unit, what does centi mean? If I have a centigram, is it 100 or 100? 100. That is 0.01. So we only use this really for length. And the way that I'm going to ask that we use all of these is always have whole numbers. I don't want us to think in fractions because it ends up being, I don't want us to think in decimals because I think it gets very confusing. So if I'm going to write 1/100th, what does that look like as a fraction instead of a decimal? So if we take this and we try to write it out as a fraction, so this is, that's how I want us using our conversion factors. So yes, you could also say that we have 0.01 meters is the same as 1 centimeter. Mathematically, these two are identical statements. Which one is easier to read? In 1 meter, there are 100 centimeters. 1 centimeter is not a whole meter. It's less than it. So this is just, it gets much more confusing by showing this relationship with one of these being a decimal and less than 1. So I'm going to ask that for every one of these conversion factors, we always write a number bigger than 1. So what's the factor? How many of the smaller one are in the big one? So what if we have a kilometer? Go ahead and compare a kilometer to a meter. What would that conversion factor look like to go between meters and kilometers or kilometers? Go ahead and write it down, and then we'll see if everyone agrees. So we're focusing here on the kilo, small k. Compare with your neighbor. How would you write a conversion factor to go between kilometers and meters? Can I have a volunteer to share what they wrote? I can't see your name. Jocelyn? Is that okay to write it that way? In the top right there? Could I write it another way as well? I also can say that 1 kilometer has 1,000 meters in it. Another way I could write this would be is this what I want you to do? Please don't. That's confusing. I want you to be able to say that in one of the bigger ones, we have a certain number of the smaller ones. And by doing that, hopefully, you'll get the hang of using them more quickly. So the ones that are highlighted in blue are the ones you're going to see more frequently. Kilo, 1,000. So basically, if I put kilo in front of anything, kilo, it means I have 1,000 of them. 1,000 grams, 1,000 meters, 1,000 moles, 1,000 anything. So you can use that in front of any value you want, and it just says that taking the place, basically saying that I'm hiding 1,000, I'm putting a K instead because it's easier. Centi, we only use really for length, like I said earlier. Centimeter, there's 100 centimeters in a meter. Milli, micro, nano. What do these three have in common? Milli, micro, nano. They're small. So these are the smaller ones. So if we had a millimeter, it's smaller than a meter. Micrometer is also smaller. But if we look at these three, What do you notice about the trend between these three values? What's that, Taylor? By, let's be more specific, something related to 3, but it's not 3. Because that's like 3, 6, 9, 12. Okay, so let's make sure we got something straight. That number is not a 6 when we look at the entire number. What is that 6 telling us? It's telling us the power. And so I don't ever want to refer to the power as the number. So the exponents are related by a power of 3. What's a power of 3 in exponent mean? Is it 10? Is it 100? 1,000? 10,000? What is a power of 3? 10 to the third? It's 1,000. So the ones you're going to make most use of in this class and in many other classes is the ones that are related by 1,000-fold difference. That's why they have femto down here, pico. But the real ones that are going to be more valuable are nano, micro, milli. And then the base unit, which is 10 to the 1, right? It's 1,000-fold different. And kilo is 10 to the third. So the 1,000-fold different. So if I'm going to talk about how far it is from here to threefold, a restaurant downtown, am I going to talk in meters? If I'm going to give you directions of or how far that is, I'm going to tell you how far to go in meters, centimeters, micrometers, nanometers, kilometers. What's an appropriate description? Probably kilometers. You might do it in meters, but you're not going to use any of these other ones. So these are kind of the ones you use for bigger things, kilo or just meter itself, and then the ones that are smaller, you just find when they're appropriate to use. We're going to practice using those a lot in lab and workshop and class. Any questions for right now? So if you have to memorize anything, it would be the ones in blue. But more importantly, make sure you can write them out as a conversion factor. Make sure you can go from kilo to this, and then know how to use that to convert between units. Jay?
So I just want to clarify, so like on the homework, they use what you exit out, like the 0.001?
They might.
Okay, so should we learn how to do that too, for like test purposes, or do you want
I want you to be able to recognize when someone's doing that,
Okay.
but I don't want you to try using that. I want you, at least until you're very comfortable converting between different units, I want you to put how many of the small one in a big one. It really is mathematically the same thing, but I think you'll get confused, you'll get lost much quicker, because then it's going to, actually we're going to do a question next that's going to showcase this. So let's just jump into that and do that. So let's go back to the packet that we had for class on Wednesday. I want you to go to the second page, third page. Third page. Go ahead and read the information there, and then go ahead and answer all the way up through question 6. Sorry, 7. We just did 6. We already did 6. And talk to your neighbor once you've read everything and question 7 on how you'd answer question 7. What's question 18? Oh, it's asking you to do it.
I mean, it's kind of like,
Compare. Cool. That's great. And if you finish 7, go ahead and do 8. They need their power. If you finish critical thinking question 7, then 8 asks you to kind of write it out yourself and show how you do it in conversion factor.
If you're done with those, you're welcome to go to model 3.
Model 3?
Yeah.
Skipping model 2.
Model 2 is for on your own time. It's super interesting, but I'm not going to do it for
Look, everything you need to do is look for
I just convert Fahrenheit to Celsius in my head. Like, I get like a rough understanding of like the temperature, so like basically, for the most part, I like to say anything in Celsius, for example, converting from Fahrenheit would be like a minus 32 times 509, and then you get like a more or less accurate like Celsius rating.
Unless we leave it at 0.
Oh, okay, yeah. I have to write it. That, yeah.
So we don't do module 2, we just skip over module 2.
That's something we've already kind of went over, so you can do that on your own. It's kind of like what you've already done.
Yeah. I have 37.
These vehicles were most carbon dioxide of 25.
Yeah, they're wanting to find the carbon dioxide.
Okay. If we're being completely honest, and you looked at question 7, can we do a thumbs up, thumbs down? Were we pretty confident we could pick out which one was right and why? Or maybe not so much? Actually, I think I have this as a clicker question. Let's do this as a clicker question. How about that? I want to see everyone's responses. Which one of these was it? And this was before we do any calculations, right? So be honest as to what your initial thought was without calculations. I think I can cheat and look at the results on my phone. Maybe. I'm not texting. I'm actually. Are you able to select A, B, C, D, E? All right. And closing out. Has everyone submitted their response? We have 54 participants today. Okay, so a large majority of people said one of these responses. Can I have a description if you're confident in your answer and why? Go ahead, Sarah.
I'll pick the 0.023 liters because you know that there are 1,000 mils in 1 liter. So you're gonna have a smaller number and not a bigger number.
Okay, great. I agree. Does anyone want to explain that a different way as well? Does that just make total sense to everyone? Sometimes there's different ways of thinking about it, and I want to draw those out. Jay?
I don't know conversions. So my first thought was, okay, which one makes more sense? Would I have 0.023 liters, or would I have 23,000 liters? And so I was like, okay, it's gonna be a smaller number
Because what?
because 23,000 just sounds ridiculous.
Okay, so yes and no. Go ahead.
The question clearly asks how many milliliters are in 1 liter. So you can't have 23,000 liters in 1 liter. It makes no sense.
Okay, so what is the fallacy that someone is pursuing that answered the inappropriate one here? What's really easy to mix up? The conversion factor is a milli is 1,000 different from the base unit. But is it 1,000 milli in a liter, or is it 1,000 liters in 1 milliliter? So this is one where, I think like Tara said in the beginning, I look at this and I say, okay, I know there's a lot of these ones, the millis, in 1 liter. A lot of them, 1,000 of them. So if there's 1,000 of the millis in one big thing, then I know that it's not going to be a whole liter. It's actually going to be less than a liter. And that's going to be, makes this answer not possible. But it's really easy, and actually going back to what Jay was saying, looks absurdly large. But if 1,000 is a difference, 23,000, it's 1,000 different. So that's where the conversion factor becomes so important, to make sure that we understand and we write how many of the small one in the big one. So even more important than knowing exactly what order it is, right, 10 to the -3rd, -6, -9, it's almost more important just to know the order. Which one is smaller than which one than which one. So how would we do this actual calculation if we wanted to do it? Can I get a volunteer from this side of the class? What would the actual unit conversion approach be? Go ahead. And I don't see your name, Tent. I forgot your name.
I forgot it, Olivia.
Olivia, thanks.
23 milliliters of 1 times 1 liter over 1,000 milliliters. And then multiplying the top is 23 over 1,000, and then simplifying it is 0.023 over 1 liter over 1.
Great. So once again, we say there are 1,000 of the small milliliters in 1 liter. So we can go and we can find out that there's less than 1, right? 1,000 over 1,000 would be 1, so it's 23 over 1,000, so it's less than 1. So only one of those two answers makes sense. Questions? Can we see how this would be a really easy trap to fall into? And can I tell you how often I see this on exams or on homework, people trying this first and just writing out 23 times 1,000. Done. Right? So that's why I'm trying to harp over and over again. Please write out your conversion factors, write them out nice and clearly, and we're going to be using those a ton in this class. So let's, got 20 minutes left in class. Do we want to spend time doing metric conversions or doing 2 units as your conversion factor?
2 units, please.
How about we split it a little bit? Let's do a tiny bit of metric first, and then we'll go. So go ahead and grab the worksheet for today. And let's go ahead and start on the front page. So single page. No, you don't have to turn this in. This is all for you. And keep it as your notes. Does anyone need one of these single pages? And I've been told that these make very good study notes. So hold on to all your work that you're doing. So go ahead and complete the first page as much as you can. We'll come and we'll talk about individual units. Please raise your hand if you have any questions about what it's asking. You have plenty of help around. Whole front page.
Units properly recorded.
Right?
What did you put for number 4? I'm tempted to say no, because this is like 6 figures here, and this is 5.
That's all I got. So what?
I just like, it says cross off the answers right at the significant figures, but like, I don't know about like, this is just straight up incorrect. Wow. Amazing.
It's asking for you to write down the conversion factor. When you're going from one to another. Yes. Are those correct or what are
So that means that they can individualize all the figures.
Oh yeah, I think they're all correct. Yeah, so that would be 3. That shuts off. You know what, I'm not sure. I feel like it only doesn't matter if it's like right in front. But like, I don't know if it's like, if that's the case, if it's sandwiched in there, I think it still matters. That's what I think, but I'm not sure.
Yeah, for some reason, pretty good.
It's because it's in the middle, it's important. But if it's like here, white stuff.
Yes, it is.
Okay, this one needs to have.
Okay.
straight up rounded it like right there, so it's like off by like 4 or 5.
I just wasn't sure if I was supposed to, because I knew it was big was wrong. I just wasn't sure if I was supposed to correctly calculate it.
Yeah.
Can you write time?
Yeah.
Or do you just write 3.9? Because I've seen it both ways. My homework is like time. Then it has to be
Personally, I would probably write it just so it's in my head.
So I got that exact time. Write it down.
This is just showing like.
All right. Let's get together for 3 minutes, and then we're going to switch gears. Thank you, Emily. All right. If we look at these, what are we identifying as our conversion factors? What are the conversion factors? Circle them, please. Come on, you can do it. All right. That's the one for the first calculation. What's the one for the second? And the third? Great. A conversion factor is the phrase that we use to describe something that allows us to convert from one unit to another. So the conversion factors are always going to have units on the top and the bottom, and those are going to describe exactly what unit we can go from and to. What's the relationship between the conversion factors in the second and the third equations? Guys, Stephanie? They're flipped. So if we put it as a sentence, what does one allow us to do versus what does the other allow us to do?
One allows us to convert from milliliters to liters, and one allows us to convert from liters to milliliters.
Fantastic. So in essence, it's the same numerical values on the top and the bottom, but they have a totally different purpose and going in different directions in that conversion. Did we agree with the calculations that they had? Were they okay? What was wrong with them? Can I get a new volunteer? Someone hasn't talked yet. What might we not agree with that was done here? Significant figures? Which one of these three, or is it all three?
Well, I started from the bottom up and I was on the bottom.
Okay, and so you don't agree with the significant figures of the last one.
Don't ask me what it was because I was trying to figure it out.
Okay, so here is one of these times where it gets a little confusing as someone new diving into significant figures. How many significant digits do we have in this first value of liters?
6.
1, 2, 3, 4, 5, 6. I agree. So we have 6 significant figures in this value here. We're doing multiplication, and there are 2 different sets of rules. One for multiplication and division, completely set for addition and subtraction. So we're doing multiplication here, and so the rule that we're going to use is that whichever value has the least number of significant figures is going to limit our answer to that many significant figures. How many significant figures does our conversion factor have in it? Infinite. This is exactly 1,000 milliliters are 1 liter. There is no uncertainty whatsoever. And we're basing this off which has the most uncertainty that limits how certain our answer is. So if we're certain of this, it's not going to change our answer significantly, or significant figures. So that means our answer should have how many significant figures? 6 significant figures. How many does this one have? This answer on the right here, how many significant figures do we have?
4.
Can I hear your response? Why 4? So this 0 right here, the way it's written is just telling us how big or small the number is. It's not saying that we're certain it is a 0. So this is certain, 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 certain. So we have 4 significant figures the way that's written right now. This 0 is not a 0 for sure. It's about a 0. And if we wanted to change that, what did you say we would do? That is how you'd write it with 5 significant figures. That says, I know when I measured specifically the ones place. This one says, well, I measured, but only accurately to the tens place. I don't know what the ones place is. So there are a whole bunch of rules, and there is a section in your book on that. I'm trying to figure out exactly how we're going to work with that. I think our lab has some decent effort on significant figures, and we'll try to incorporate more in class. But this is inappropriate. So what would the right answer be? Go ahead, Dustin.
I got 87,034.5 milliliters.
1, 2, 3, 4, 5, 6 significant figures. That is correct. What about the other two? Are those okay? We have 4 significant figures here. That 0 just tells us it's small. That's the only reason that 0 is there. 1, 2, 3, 4. Don't limit by the conversion factor here. 1, 2, 3, 4. And then we say it's very small. So scientific notation is a really good way to kind of overlook. The other way we could write this, right, that's the same thing as... But here it gets a little confusing because if we're not 100% certain, we're like, well, do these count or not? They don't, but it's much easier to see by saying, well, this tells us it's small, and then this is the numeric value of the small thing. So if this looks like gibberish to you, you need to spend some time with significant figures, and more specifically, scientific notation. It's very common to be a little mixed up with scientific notation, so dedicate some time to learning how to use scientific notation, and that's going to save you a lot of time and heartache. This top one here, 20.5, 3 sig figs. Our answer is 3 sig figs, so we're good.
So I thought if it was zeros after the decimal, they were significant. But the ones before.
If there are zeros after your significant values, they are significant.
Oh, okay.
But that would be out here. Because the reason that these zeros are not significant is if you take that away, it changes how big or small it is. That's totally different from if you have a 0 here.
Okay.
If you have a 0 there, it doesn't change how big or small it is. It just says, how well do I know that value? So that's kind of a question you can ask. All right, so let's spend the last 4 minutes of class. Let's flip back to Model 3 of last week's activity. And go ahead and start reading through Model 3. And I'm going to throw up some quicker questions to get us started on it. Model 3, which is carbon footprint. So make sure to read Model 3, read the top part of that and the table, and then I'm going to ask us a quicker question. All right, our first quicker question is up. And as you're leaving class in 2 minutes, not yet, if anyone wants a chocolate Turkish moon pie, you're welcome to come grab it. All right, a couple more seconds to answer this question. I want to make sure that we're all reading that top section correctly. Try refreshing, go out of the session and back in. All right, where do we find this information? All right, so our top, looks like a lot of us got that. By the way, just think logically. If we burn 1 gallon of gasoline, do you think about how much 18 pounds is? Once again, standard units. Pretty significant. That's how much CO2 we're putting in the air. All right. Did we still have a minute? Don't back up. It's not nice. It's not nice to back up before class is over. So I'm going to go ahead and ask the question that's listed for number 15. If we drive 25 miles, which one of these is going to use, which will produce more carbon dioxide? And then I want you thinking about, once you have done the logic check, so logic, no calculations. Once you've done this without any calculations, then how would you actually calculate it? Turns out you can do that from here. How did we make this decision? How did we come to this point where most of us are saying that answer C is going to release the most CO2? It's less efficient, of course, right? Could you calculate it? All right, so this is where you're going to take the multiple step conversion factors and you're going to be putting them together. We'll start off class, the very beginning class on Wednesday with this, but we're only going to spend about 15 minutes on this, and then we're going to start on atomic, what are atoms made of, and that kind of stuff, okay? So all the rest, Model 2, and the back side of that conversion sheet, those are things for you to practice on using the metric system. So please make sure that you're up to speed, and if you're not, use your resources. All right, have a good night.